The Saunders Generating Station. With a 920,000 kilowatt capacity, it is one of the largest hydraulic generating stations in the province. Its construction in the 1950s was a tremendous engineering achievement and added another colorful chapter in the history of the St. Lawrence River. The St. Lawrence River has long played an important role as a major transportation route. Stretching 3,500 kilometers from the Great Lakes to the Atlantic Ocean, the St. Lawrence pointed the way to the heart of the continent for the explorers and settlers of the 17th century. But canoeing up the St. Lawrence was a difficult journey for the early traders. Often, canoes had to be carried overland to avoid treacherous stretches of water like the Long Sault Rapids, 75 kilometers of fast-moving currents and dangerous rocks. To overcome this navigation problem for larger vessels, a system of locks and canals was developed throughout the 19th century. But early in the 20th century, the St. Lawrence began to play an additional role when a number of small hydroelectric projects were built on the Quebec section of the river. The river's greatest source of power, though, was the 28-meter drop in elevation between Lake Ontario and the city of Cornwall, the feature of the river responsible for the Long Sault Rapids. How ironic that the mariner's nightmare turned out to be the engineer's dream. The first Ontario hydro surveys and studies were conducted in 1913. But because the Canada-US border runs along the middle of the river, complex and lengthy negotiations were inevitable. The situation was further complicated when it was realized it was best to build the power project in conjunction with an expanded canal system, or Seaway. The proper balance had to be struck between the need for increased shipping capacity and more electricity. Both the Seaway and the power project presented great challenges to the engineering capabilities of the day. The expertise of Ontario Hydro and the New York Power Authority was combined to make the dream of power from the St. Lawrence a reality. For over 40 years, engineers on both sides of the border awaited the outcome of complex negotiations. Finally, in 1952, preliminary work got underway. The information gathered during the earlier investigations was checked and updated. Ontario Hydro engineers and technicians measured water velocities, metered the flow of the river, and made hundreds of soundings to determine the shape of the river bed. Observations were also made of the behavior and formation of river ice, an important consideration in the design of a power plant which must continue to operate efficiently despite the extreme conditions of winter. From the data collected, hydraulic engineers built scale models of the project. Using models to test the design and location of structures and waterways ensured the most effective use of the river's resources and saved both time and money in the long run. When negotiations were at last concluded in June of 1954, the engineers were ready to go. On August 10th, sod turning ceremonies were held on each side of the border. Ontario Hydro, in partnership with the New York Power Authority, started work without delay. On the Canadian side, one of the first problems to be solved was getting men and materials across the Cornwall Canal to the powerhouse site without disrupting the shipping traffic. It was impractical to build a bridge with sufficient clearance for the tallest ships. The solution was to tunnel under the canal. When the navigation season closed in 1954, a section of the canal was drained off and an open cut excavated across the canal bed. 2 steel tubes, 5 meters and 3 meters in diameter, were assembled in sections, then dragged into the excavation and bolted together. The excavation was filled in and the canal banks restored. By the spring of 1955, lines of vehicles were passing through the large tunnel while lake freighters steamed past overhead. Some equipment, however, was far too large to pass through. A junior engineer suggested using a retractable Bailey bridge at the Cornwall Lock. Originally designed for military purposes in World War II, Bailey bridging has since been used extensively on civil engineering works. The project involved coordinating the simultaneous construction of 3 main structures. The powerhouse that spans the river's north channel at Barnhart Island, the Long Sault Dam 5 kilometers upstream in the river's south channel, and a smaller dam further upstream at Iroquois to control the outflow of Lake Ontario. The Long Sault Dam was built to limit the flow of the river primarily to one channel in order to carry out the carefully controlled flooding that created the dramatic man-made change in geography we now call Lake St. Lawrence. Hydraulic engineers call this body of water a head pond. The purpose of the head pond is to concentrate, at one point, the once gradual drop in elevation and water that occurred between Lake Ontario and the powerhouse site near Cornwall. It is this concentrated, rather than gradual fall of water that has made it possible to generate large amounts of hydroelectricity from the St. Lawrence River. But how were the project's massive structures, a powerhouse and 2 dams, actually built in the middle of the St. Lawrence River? The answer was cofferdams, temporary, watertight barriers that enclosed sections of the river that were then pumped dry. To build the Long Sault Dam, a short canal was dug across the tip of the island to divert the river around the cofferdammed area. The southern part of the dam was then built within the dry enclosure. To construct the northern part of the dam, another diversion had to be made. A large channel was made to divert the river into its natural south channel, and the water passed through the open sluice gates of the completed southern part of the dam. The Long Sault Rapids were sealed off with a cofferdam at each end and pumped dry. Construction of the northern part of the Long Sault Dam proceeded to completion. The Iroquois Dam was built on what was once a bend in the river. Construction of the southern part of the dam, therefore, was carried out on the original shore with only a small cofferdam to keep the water out. When this section of the dam was finished, the original shoreline was removed, leaving the structure in the water. A cofferdam was built from the north shore and the dam completed without interfering with the normal flow of the river. Meanwhile, at the powerhouse site, while the tunnels and Bailey Bridge were being built, a 4-kilometer-long section of the river was being enclosed by 2 cofferdams. The cofferdam just downstream from the powerhouse site was over 1 kilometer long and was constructed of 60 interlocking sections. The raft-like sections were assembled on shore and then towed into position. Once anchored, they were wrapped with interlocking sheet steel piling driven into the riverbed. Trucks filled in the cofferdam cells with earth and rock. Once the upstream cofferdam was in place, the enclosed area was pumped dry. By the summer of 1955, while the riverbed was being prepared for the laying of the powerhouse foundations, cofferdams were being placed in the South Channel at Long Sault Island, and construction of the first half of the Iroquois Dam was underway. A project of this magnitude often requires innovative construction techniques, as well as tremendous quantities of materials. About 2 million metric tons of concrete were used in the Canadian section of the powerhouse. Some of the wooden forms used were particularly complex. This large scroll case had to be built with considerable precision and, at the same time, be strong enough to support the great weight of the concrete until it hardened. Concrete was mixed right on the site. Cement was brought in by rail, while a conveyor system maintained a fast and adequate supply of sand and crushed stone from nearby stockpiles. In the mixing plant, these ingredients were carefully weighed and mixed according to the specifications prepared by the Concrete Control Laboratory. On the Canadian side, concrete pouring started in February 1956 and continued with hardly a break through the month that followed. During the height of concrete operations, an average of 3,600 metric tons a day were poured. Even winter temperatures well below 0 degrees Fahrenheit, minus 18 Celsius, failed to stop the work. Ontario Hydro pioneered year-round concreting and had plenty of winter construction experience on projects from Niagara Falls to Northern Ontario. The concrete was mixed with heated sand and water. The formwork was then insulated and protected from the wind by tarpaulin screen, while steam heaters maintained the correct temperature for the hardening and curing of the concrete. By the end of 1956, the results of a little over 2 years of steady work were clearly visible. At the powerhouse, the parts of the turbines that had to be embedded in concrete were being installed and leveled. At Iroquois, the first half of the dam was finished, and work was going ahead on the construction of the second half. The first stage of the Long Sault Dam was completed, and work was underway on the diversion channel and cofferdams needed to seal off the rapids. When the familiar wild rush of the Long Sault Rapids was stilled in the summer of 1957, the silence was strange and unreal. Progress is not without sacrifice or inconvenience. Creating the head pond flooded out 3,200 hectares along the Canadian shoreline, displacing 6,500 residents of a number of small towns and villages. At Iroquois, it was decided to re-establish the entire village at a new site about 2.5 kilometers to the north. Only part of Morrisburg was affected, so a new subdivision was laid out to take care of the homes and businesses originally located along the natural shoreline. To absorb the smaller communities, 2 new towns were created. Located about 25 kilometers west of Cornwall, the town of Ingleside combined the former villages of Wales, Dickinson's Landing, Farron's Point, and Altsville. The new town of Long Sault absorbed the residents of Mille Roche and Moulinet. For many of the people involved, relocation meant a brand new house in a strange new town. But for others, it was their familiar old house with a change of address. Over 500 homes were transported by house-moving machines. Many new houses had to be built too. New shopping centers, schools, churches, and municipal buildings were also built, along with all the necessary roads, sewers, streetlights, and other services. To link this new chain of communities along the St. Lawrence, about 65 kilometers of double-tracked railway lines was rerouted, as was 55 kilometers of the old number 2 highway. Another task carried out in preparation for the filling of the head pond was the construction of protective dikes. Tons of local clay were moved in and compacted into watertight structures capable of protecting low-lying areas from flooding. In 1958, construction of the power project was in the home stretch. as the graceful curve of the Long Sault Dam was extended towards the western end of Barnhart Island. The other man-made barriers, built to impound the waters of the St. Lawrence, were also nearing completion. The Iroquois Dam, built to control the outflow of water from Lake Ontario, was put into operation. At the powerhouse, workers were completing the installation of the turbines and generators. The Canadian and American generating stations were each outfitted with 16 units, giving them installed generating capacity of 920,000 kilowatts per station. When all was finally in readiness at the powerhouse, the next event on the 4-year-long construction agenda was a dramatic one: the filling of the head pond. Under the supervision of Ontario Hydro's chief engineer and the project director, the cofferdam upstream from the powerhouse was loaded with 30 tons of explosives. For the many long-time residents of the area, people whose ancestors had pioneered the St. Lawrence Valley, July 1st, 1958 was a day they would not forget. The climax of years of planning and construction was at hand. A river control center at the powerhouse was standing by to monitor the flooding once the cofferdam was breached. With that explosion, the head pond, Lake St. Lawrence, was created. The event marked the end of many associations with the past and the beginning of a new era. The Robert H. Saunders Generating Station was officially opened on Friday, September 5th, 1958. At a special commemorative ceremony in June of 1959, attended by Prime Minister Louis Saint Laurent and Vice President Richard Nixon, Her Majesty Queen Elizabeth II echoed Ontario's pride in this major engineering achievement.
I am particularly proud to unveil this memorial. In doing so, I express the hope, which I am sure everyone here shares, that this example of international cooperation may prove infectious. I hope and pray that it may bring the day a little closer when all the nations of the world may turn away from the fortifications of fear to work together in the ways of peace, and all men may share in the dreams and accomplishments of their brothers.
Since 1958, Ontario Hydro's Robert H. Saunders Generating Station has provided the people of this province with a reliable and economical source of electricity. 920,000 kilowatts. That's almost half of the generating capacity at Ontario Hydro's Niagara Falls stations, and close to the generating capacity of 2 nuclear reactors at Pickering. Best of all, it's a source of energy that will be available to use for as long as the river flows.